viewers. Today we are going to discuss the fabrication process of the CMOS or complementary MOSFET. CMOS or complementary MOSFET is an active device consists of one N-type MOSFET with source S, gate G, drain D and body B terminal and other P-type MOSFET with the same 4 terminals. Step 1. First, a base is chosen for fabrication. A P-type silicon substrate is selected for N-well fabrication. Step 2. Oxidation. SiO2 is laid out by oxidation process done exposing the substrate to high quality oxygen and hydrogen in an oxidation chamber at approximately 1000 degrees Celsius. The selective diffusion of N-type impurities is accomplished using SiO2 as a barrier which protects portions of the wafer against contamination of the substrate. Step 3. Growing of photoresist. In this stage, the wafer is coated with a uniform film of a photosensitive emulsion. At this stage, to permit the selective etching, the SiO2 layer is subjected to the photolithography process. Step 4. Masking. This step is the continuation of the photolithography process. In this step, a desired pattern of openness is made using a stencil. This stencil is used as a mask over the photoresist. The substrate is now exposed to UV rays. The photoresist present under the exposed regions of mask gets polymerized. Step 5. Removal of unexposed photoresist. The mask is removed and the unexposed region of the photoresist is dissolved by developing wafer using a chemical trichloroethylene. Step 6. Etching. The wafer is immersed in an etching solution of hydrofluoric acid which removes the oxide from the areas through which dopants are to be diffused. Step 7. Removal of whole photoresist layer. During the etching process, those portions of SiO2 which are protected by the photoresist layers are not affected. The photoresist mask is now stripped off with a chemical solvent, hot H2SO4. Step 8. Formation of N-well. The N-type impurities are diffused into the P-type substrate through the exposed region, thus forming an N-well. Step 9. Removal of SiO2. Hydrofluoric acid is used to remove SiO2. Step 10. Deposition of polysilicon. Polysilicon is deposited by using chemical deposition process over a thin layer of gate oxide. This thin gate oxide under the polysilicon layer prevents further doping under the gate region. Polysilicon is used for formation of the gate because it can withstand the high temperature greater than 8000 degrees Celsius when a wafer is subjected to annealing methods for formation of source and drain. Step 11. Formation of gate region. Except the 2 regions required for formation of the gate for NMOS and PMOS transistors, the remaining portion of polysilicon is stripped off. Step 12. Oxidation process. An oxidation layer is deposited over the wafer which acts as a shield for further diffusion and metallization process. Step 13a. Masking and diffusion. For making regions for diffusion of N-type impurities using masking process, small gaps are made. Step 13b. Masking and diffusion, N+ region formation. Using diffusion process, 3 N+ regions are developed for the formation of terminals of NMOS. Step 14. Removal of oxide. The oxide layer is stripped off. Step 15. P-type diffusion. Similar to the N-type diffusion for forming the terminals of PMOS, P-type diffusion are carried out. Step 16. Laying of thick field oxide. Before forming the metal terminals, a thick field oxide is laid out to form a protective layer for the regions of the wafer where no terminals are required. Step 17. Metallization. This step is used for the formation of metal terminals which can provide interconnections. Aluminium is spread on the whole wafer. Step 18. Removal of excess metal. The excess metal is removed from the wafer. Step 19. Formation of terminals. In the gaps formed after removal of excess metal, terminals are formed for the interconnections. Step 20. Assigning the terminal names. Names are assigned to the terminals of NMOS and PMOS transistors. In today's lecture, we have learned CMOS structure, CMOS fabrication steps. With this, we are at the end of this lecture. In the next lecture, we will discuss another topic. Thank you and goodbye.